A DVD player primarily functions to play DVD and other optical media formats. It decodes and displays video and audio signals. Functionality allows for navigation and playback control. Some DVD players may include additional features such as upscaling, smart functionality, and Bluetooth connectivity. If wanting to watch DVD in another room from a DVD player in a different location using a 40-foot wire extension, there are several things to keep in mind. Firstly, long wire runs can cause signal attenuation, leading to a weaker or distorted signal. Secondly, using high-quality coaxial or HDMI cables for the extension will minimize signal loss. Thirdly, avoid running the cables near power lines or other electrical sources to prevent interference. Fourthly, ensure that the DVD player and TV are properly grounded to prevent electrical noise from affecting the signal. Coaxial cables have a maximum recommended length of 100 feet, while HDMI cables are generally limited to around 50 feet. To ensure the best possible signal quality, consider using a wireless HDMI transmitter or receiver system. These systems transmit the video and audio signals wirelessly, eliminating the need for long wire runs. If using wires, the procedure is as follows. 1. T-tap the coaxial or HDMI cable from the DVD player output. 2. Run the extension cable from the T-tap to the TV input. 3. Secure the connections with cable ties or connectors. 4. Turn on the DVD player and TV to test the connection. It is advisable to use a cable tester to verify the integrity of the extension cable before connecting it. If there are any signal issues, a shorter cable or a higher quality cable may resolve them. If needing to extend the distance further, consider using a signal booster or amplifier. Let's delve deeper into the specifics of signal attenuation. Signal attenuation refers to the loss of signal strength as it travels along a cable. This is an inherent property of electrical conductors, and the amount of attenuation depends on several factors, including the length of the cable, the frequency of the signal, and the quality of the cable itself. In the context of extending a DVD player signal attenuation can manifest as a dimmer picture, reduced color vibrancy, or even complete signal loss. To mitigate signal attenuation, it's crucial to use high-quality cables with low attenuation characteristics. These cables typically employ better shielding and higher-grade conductors to minimize signal loss. The choice of cable type also plays a significant role. Coaxial cables, while robust and capable of handling long distances, may introduce more attenuation than HDMI cables, especially at higher resolutions and refresh rates. HDMI cables, on the other hand, are designed to carry high bandwidth digital signals with minimal loss, but their effective range is generally shorter. Therefore, selecting the appropriate cable type and length is essential for maintaining signal integrity. In addition to cable quality, proper termination and connection techniques can also help reduce signal attenuation. Loose or corroded connectors can introduce significant signal loss, so it's important to ensure that all connections are clean, tight, and properly shielded. Using high-quality connectors and crimping tools can further enhance connection reliability and minimize signal attenuation. Now let's explore the different types of cables that can be used for extending a DVD player signal. The two primary options are coaxial cables and HDMI cables, each with its own set of advantages and disadvantages. Coaxial cables are a well-established technology for transmitting radio frequency signals, including video and audio. They consist of a central conductor surrounded by an insulating layer, a braided shield, and an outer jacket. The shield provides excellent protection against electromagnetic interference, making coaxial cables suitable for long-distance runs in environments with potential noise sources. However, coaxial cables are typically limited to lower resolutions and refresh rates compared to HDMI cables, and they require separate cables for video and audio signals. HDMI cables, on the other hand, are designed to carry high-bandwidth digital signals, including high-definition video and multi-channel audio. They use a single cable to transmit both video and audio, simplifying connections and reducing cable clutter. HDMI cables also support advanced features such as HDCP content protection and CC device control. However, HDMI cables are generally more susceptible to signal attenuation over long distances, and they may be more vulnerable to electromagnetic interference. When choosing between coaxial and HDMI cables, it's important to consider the specific requirements of the application. For shorter distances and lower resolutions, HDMI cables may be the preferred choice due to their superior signal quality and ease of use. However, for longer distances or environments with high levels of interference, coaxial cables may provide a more reliable and robust solution. In some cases, it may be necessary to use a combination of both cable types, with coaxial cables used for the long-distance run and HDMI cables used for the final connection to the TV. In addition to coaxial and HDMI cables, other options for extending a DVD player signal include component video cables, composite video cables, and S-video cables. However, these cable types are generally older and offer lower signal quality compared to coaxial and HDMI cables. Therefore, they are typically not recommended for extending a DVD player signal unless there are specific compatibility issues or limitations. Next, let's discuss electrical interference and how to prevent it from affecting the DVD player signal. Electrical interference, also known as electromagnetic interference or radio frequency interference, refers to unwanted electrical signals that can disrupt or distort the intended signal. These interference signals can originate from various sources, including power lines, electrical appliances, wireless devices, and even atmospheric phenomena. When electrical interference affects the DVD player signal, it can manifest as static, noise, or distortion in the video or audio output. In severe cases, it can even cause complete signal loss. To prevent electrical interference from affecting the DVD player signal, it's important to take several precautions. Firstly, avoid running the cables near power lines or other electrical sources. Power lines and electrical appliances can radiate strong electromagnetic fields that can induce unwanted signals in the cables. Secondly, use shielded cables with good shielding effectiveness. Shielded cables have a layer of conductive material, such as braided copper or aluminum foil, that surrounds the inner conductors and blocks out external interference signals. Thirdly, ensure that all connections are properly grounded. Grounding provides a path for unwanted electrical signals to flow to ground, preventing them from interfering with the desired signal. Fourthly, use ferrite beads or chokes to filter out high-frequency noise. Ferrite beads are small magnetic devices that can be attached to cables to suppress unwanted high-frequency signals. In addition to these precautions, it's also important to keep the cables as short as possible and avoid running them parallel to other electrical cables. Shorter cables are less susceptible to interference, and running cables perpendicular to each other can reduce the amount of coupling between them. Finally, consider using a power line conditioner or surge protector to filter out noise and protect the equipment from voltage spikes. A power line conditioner can clean out the incoming power supply, removing unwanted noise and fluctuations, while a surge protector can protect the equipment from damage caused by voltage spikes. Grounding is an essential aspect of electrical safety and signal integrity. Grounding provides a path for unwanted electrical currents to flow to ground, preventing them from causing harm to people or equipment. In the context of extending a DVD player signal, grounding helps to prevent electrical noise from affecting the signal and ensures that the equipment operates safely. To ensure proper grounding, it's important to follow these guidelines. Firstly, ensure that the DVD player and TV are connected to a properly grounded electrical outlet. A properly grounded outlet has a third prong that connects to a grounding wire, which in turn connects to the building's grounding system. Secondly, use shielded cables with good grounding continuity. Shielded cables have a conductive shield that is connected to the grounding system, providing a path for unwanted electrical signals to flow to ground. Thirdly, ensure that all connections are tight and corrosion-free. Loose or corroded connections can introduce resistance into the grounding path, reducing its effectiveness. Fourthly, consider using a grounding block or distribution block to provide a central grounding point. A grounding block is a device that provides multiple grounding connections, allowing you to connect all of the equipment to a single grounding point. In addition to these guidelines, it's also important to consult with a qualified electrician to ensure that the grounding system is properly installed and maintained. A qualified electrician can inspect the grounding system, test its effectiveness, and make any necessary repairs or upgrades. Distance limitations are an important consideration when extending a DVD player signal. As the signal travels along a cable, it gradually weakens due to signal attenuation. Eventually, the signal may become too weak to be properly decoded by the TV, resulting in a degraded picture or complete signal loss. The maximum recommended length of a cable depends on several factors, including the cable type, the signal resolution, and the quality of the cable. Coaxial cables typically have a maximum recommended length of 100 feet, while HDMI cables are generally limited to around 50 feet. However, these are just general guidelines, and the actual maximum length may vary depending on the specific circumstances. To determine the maximum recommended length for a particular cable, it's important to consult the manufacturer's specifications. The manufacturer's specifications will provide detailed information about the cable's attenuation characteristics and its recommended maximum length for various signal resolutions. If you need to extend the signal beyond the maximum recommended length, there are several options available. Firstly, you can use a signal booster or amplifier to amplify the signal and compensate for signal attenuation. A signal booster is a device that amplifies a signal without changing its characteristics, while an amplifier is a device that amplifies the signal and may also modify its characteristics. Secondly, you can use a higher quality cable with lower attenuation characteristics. Higher quality cables typically use better shielding and higher grade conductors to minimize signal loss. Thirdly, you can use a wireless HDMI transmitter or receiver system to transmit the signal wirelessly, eliminating the need for long cable runs. As an alternative to using wires, consider using a wireless HDMI transmitter or receiver system. These systems transmit the video and audio signals wirelessly, eliminating the need for long wire runs. Wireless HDMI systems consist of a transmitter unit that connects to the DVD player and a receiver unit that connects to the TV. The transmitter unit encodes the video and audio signals and transmits them wirelessly to the receiver unit. The receiver unit decodes the signals and outputs them to the TV. Wireless HDMI systems offer several advantages over wired connections. Firstly, they eliminate the need for long cable runs, which can be unsightly and difficult to manage. Secondly, they provide greater flexibility in terms of placement, allowing you to position the DVD player and TV in different rooms without having to worry about running cables through walls or floors. Thirdly, they can be easily relocated or reconfigured as needed. However, wireless HDMI systems also have some limitations. Firstly, they are generally more expensive than wired connections. Secondly, they may be susceptible to interference from other wireless devices, such as Wi-Fi routers and microwave ovens. Thirdly, they may introduce some latency or delay in the signal, which can be noticeable in some applications. When choosing a wireless HDMI system, it's important to consider the following factors. Firstly, the range of the system. The range of the system determines how far apart the transmitter and receiver units can be placed. Secondly, the resolution and refresh rate supported by the system. The system should support the resolution and refresh rate of the DVD player and TV. Thirdly, the number of HDMI inputs and outputs. The system should have enough HDMI inputs to connect all of the desired devices. Fourthly, the level of security provided by the system. The system should use encryption to protect the signal from unauthorized access. The procedure for connecting the DVD player to the TV using wires is as follows. 1. T-tap the coaxial or HDMI cable from the DVD player output. A T-tap is a connector that allows you to tap into an existing cable without cutting it. T-taps are commonly used for connecting multiple devices to a single cable. 2. Run the extension cable from the T-tap to the TV input. The extension cable should be of the same type as the original cable. 3. Secure the connections with cable ties or connectors. Cable ties and connectors help to keep the connections tight and prevent them from coming loose. 4. Turn on the DVD player and TV to test the connection. If the connection is successful, you should see the DVD player's output on the TV screen. Additional tips. Firstly, use a cable tester to verify the integrity of the extension cable before connecting it. A cable tester is a device that checks the continuity and signal quality of a cable. Using a cable tester can help you to identify any problems with the cable before you connect it to the equipment. Secondly, if there are any signal issues, try a shorter cable or a higher quality cable. Shorter cables and higher quality cables are less susceptible to signal attenuation and interference. Thirdly, if there is a need to extend the distance further, consider using a signal booster or amplifier. Signal boosters and amplifiers can help to compensate for signal attenuation and allow you to extend the signal over longer distances. In conclusion, extending DVD playback to another room is possible, but requires careful consideration of signal attenuation, wire type, electrical interference, grounding, and distance limitations. By following these guidelines, it is possible to achieve a high-quality video and audio experience in any room.